Well, hello everyone. This is Mr. Gutchuck, and you are back um, to learn something more about trigonometry and hopefully how to find and use and apply the trigonometric identities um, and proper strategies to do that. Okay, so today I'm going to go through and just offer some more examples, work through examples for those that may need it on section 10.2 on how to simplify trig expressions. So without further ado, let us move on. I have some problems up here, and I'm going to go through these, and you can kind of follow along. These are ones that you didn't have in your homework, but ones that you might see on a quiz, which you're going to have on Wednesday of this week. So, or maybe if you're just following along at home, ones that you may see in the future. So, how do you solve these? Well, there are different strategies of going through here. And in order to solve these, a lot of the strategies happen to be where you're trying to get to it on one side is you need to look at what we are trying to get to, okay, and what do we have. And many times with one of the strategies is the first thing is you want to see if there's any identities that can be used. So any possible identities. Titties. So right here, let's see if there's any possible identities. Well, 2 is 2, okay. Then we have negative secant squared. Well, secant squared, yes, that is a possible identity. If you remember one of the fundamental tree identities, all right, one of the fundamental tree identities is secant is actually, if you recall, I'm going to just put this on the side, 1 plus tangent squared of, in this case, we'll put z, equals secant squared of z, all right? Secant squared of z, that's a square, by the way. All right, so yeah, so if we solve this, we know that secant squared is actually going to be 1 plus tangent squared. So we're going to use that. That's one of the fundamental trig identities. That's the one thing we can look for right here. And so we're going to write this as 2 minus one of these identities, which is going to be tangent squared of z, all right? And it's going to be, oops, I forgot +1, put +1 here. It can be in any order, all right? Give me the property. And so now what we're going to do is, once we have used the fundamental trig identity, and now we're going to simplify. Okay, so we're going to simplify this. And what we can do is take that negative and distribute it through. So now we have 2 minus tangent squared of z, and that's going to be -1 because we distribute it all the way through to each one. And now we simplify, so now we have 1 minus tangent squared of z. And bada bing, bada boom, that, my friends, is our answer because it matches exactly what we wanted to do right there. And we're done. Okay, so that's one of the strategies that we can use. All right, well, let's apply one of these strategies over here. Okay, so we have tangent of pi over 2 minus theta. And so we're looking at that and we say, well, we have to get it so it looks like, all right, the left side, or sorry, the right side over here. So let's start with our first thing. Any possible identities? Well, this right here is a cofunction identity, if you recall. And the cofunction identity, we know that tangent of 90 minus theta. We learned that back in chapter 9. All right, and it's on your trig bit sheets. And if you don't have a trig bit sheet, get one. And so we have is tangent is actually going to equal cotangent. All right, cotangent of theta. Now that's going to be times tangent of theta. Now, from here, you might know, you might be able to figure this out, saying, oh yeah, that equals 1. But if you don't know, well, cotangent, what's cotangent? Cotangent is the reciprocal, right? That's another identity. We know that's going to be 1 over tangent of theta times tangent of theta. There we have it. Once we have that right there, we're going to doop, boop, cancel out because they're multiplied here, and guess what they equal? 1. And that's exactly what we're looking for right there. Awesome, right? Let's try this again. See what we have here. Now, this one, okay, this one right here, any possible identities? Well, we want to get sine in here. Well, I guess secant, I guess that is an identity. We can write it as 1 over cosine of x. So this brings us to our next problem. Okay, I'm going to put that down right here because we're going to make it look like that. is that if you notice that there's now possible identities like we had in the top two, the second thing you might want to do is write everything as sine of x and cosine of x. All right, you want to write that as sine and cosine. I apologize that my writing is horrible. I'm sorry. But you want to write everything as sine and cosine. And then I'll just say do algebra. All right, do algebra. Okay, do algebra. So right here, secant is 1 over cosine. All right, right here we have cosine. Well, now we do algebra. What does that mean? Well, that means that this is a fraction. This is not a fraction. Well, to combine these, because notice how these are kind of combined. All right, there's no subtraction, so we're going to combine them. Combine by adding, or actually subtracting. Combine by subtraction. Subtract. And how do we subtract? Well, we're going to use, right here, a common denominator. So what's our common denominator? Well, it's cosine. So we're going to have 1 cosine of x, and I'm going to take cosine. We're going to multiply that top to bottom, because that's how you find fractions. All right, using trig, and same thing in for regular algebra arithmetic. So now what we have is 1 minus cosine squared of x over cosine of x. Sweet. We're going to simplify this because now, after you have this, go back to do algebra, but now look for all possible identities. All possible identities. So, and it's just kind of this back and forth that we do for our strategy. So now right here, what are our identities? All right. Look for identities. And what is that? Well, that's going to be sine, right? 1 minus cosine squared, you have to know is sine squared of x. That's one of the fundamental trig identities. And now we have cosine of x. We look back over here. We have that. But now, what do we next? Well, write everything in sine and cosine. It's already written sine and cosine. Well, let's go one step farther. Is now we have to separate it and make it look like this. So sine squared is actually sine of x times sine of x all over cosine of x. Well, what's cosine over cosine? Well, that's going to equal tangent of x times sine of x, which you know, my friends, is exactly, we rewrite it just like that one. Okay? And so that is how you simplify and solve these. Okay? You start on the left side, and you first look for possible identities. You use one of the possible identities if it's there, and then you do algebra afterwards to simplify it. I'll get there. Over here, find an identity. All right. Find another identity, simplify, you get your answer. Last one, we didn't have an identity. Well, it kind of did, but secant goes into 1 over cosine, one of our cosine identities, and then we go through and then we do algebra. We combine, go back and use an identity, and then we go and simplify and get our answer. We're going to go through some more, but this is where I'm going to stop right here because it's getting a little bit long video. So hopefully this can help you out and help you figure out how to do some of those other problems as you do work on this on your own. Okay? So good luck and God bless.